and subtract rational expression, so unit 5 less than 4. Again, this is not in the midterm, but it's going to be, we're checking forward so we have time to make sure we have time at the end to prepare for the final and whatnot. But anyways, it's important to factor the denominators now. So the thing is, we're going to add the piece where we need to factor the denominators so we see what we're missing. So before, they just gave us what the stuff we need. So here, we need x plus 1, x plus 2. We need 3, we need 4. Okay, we're on page 393, guys. So now we don't see what they have in common right away. Okay, so like 5x plus 5, 2x plus 2, we want to factor those, take out a GCF. Okay, so we have one little extra step today. All right, so we'll do the first one. The first one, you don't have to factor, right, because it's a monomial, but how can I make a 5x a 10x? Yeah, 2 to top and bottom, so that one's not too bad. So 6 over 10x minus 3 over 10x. I get 3 over 10x. That's your simplified, rational expression. My non-permissible is 0. Okay, so we can't be 0. Okay. So this is where it gets a little bit tricky. Okay. Before you do 5x plus 5 and 2x plus 2, which is going to make you have more work, pull out of 5, pull out of 2. What does that show you now? Not cross them, but that shows you that you have the same, right? So we don't need an x plus 1 added anywhere. They both have x plus 1. It's common. So the only thing they're missing is the 5 and the 2 is different. So I want to multiply this by 2 and this by 5 only. See, that's nice because I don't have to do any extra x's. Does that make sense? So I factored that to see that this binomial matched up. I only had to change the coefficients to be like. Okay, the coefficient's the number in front, if you're reading that vocab. Okay, so the top of this one is going to be 8, 10 times x plus 1. And the top of this one is going to be 15, 10, x plus 1. So the bottoms match like we hoped. Now we can add them. It's 23 over 10, x plus 1. Okay. What's that? Oh, that's fun. Good. Okay. Non-permissible here is what? Negative 1. Good. Non-permissible is can't have negative 1. Okay. Good. Now, people have tried this one a few times, and I'm not saying it's silly to be mean, but I can't go plus 2x plus 2x. Okay? You can only do common denominators multiplication. You can't add a top and bottom because it's not the same thing. Okay? Why? Well, let's talk about it just real quick. Remember, we're doing stuff to top and bottom. We multiply. That value is the same, right? Like 2/3 and 4 over 6 is the exact same value. So watch. If I take 2/3 and I go plus 2, that becomes 4/5. That is not the same value as 2/3. That's why you know you've changed things inappropriately. Does that make sense? So you can't do that rule. Sometimes me talking about it makes you try it. But just letting you know you can't go plus 2, 6 plus 2, 6. So what we want to do here is we want to go ahead and take out an x. And we get x plus 2 here. And we have x squared here. That's all we can have there. So this is about asking, what do you have, what do you need? I'll say it again. What do you have, what do you need? So for example, when I'm comparing the right side to the left side, does the right side have an x squared anywhere? No. So that's the only thing it's really missing, right? This needs an x squared. Go. Right, but then it's separate, though. We want a multipled x squared. So like we want it to be x squared times something. Because we're going to have to get this to have an x plus 2, right? But Gavin, I see what you're saying. So I'm going to multiply this one by x and by x, because that gets me an x squared. So now I've matched the x squared from the left. Okay, what's the left side need? Just needs this. So I'm just going to do this one by x plus 2. And so you can see my common denominator is x squared x plus 2. Do you guys see that? So the right side, we just added an x to get the x squared. The left side, we added an x plus 2 to get the x squared plus or times x plus 2. Okay? And so now we have to do the top real quick. So the top, they're both 1s, which is nice. So you can see it's going to be x plus 2 and x here. Okay? So this one, x minus x. My x goes away, actually. It's just going to be 2 over x squared times x plus 2. That's your simplified rational expression. And we're going to state on our permissibles to finish, and I'll take any questions. Non-permissibles are what? 0, negative 2. Yep. 0, negative 2. Okay, any questions? Oh, yeah, that stuff. We're good? Oh, yeah. Okay. All right. Lesson's not too long today. It's just a few examples, I think. Yeah, just 1. Okay, so this one, simplify, starting with stating restrictions on the x values. So remember, you can get your non-permissibles right away as well. So this one's non-permissibles is -1, 2, and -4. That's my non-permissibles. That won't change. Okay, that won't change. And so what's important to recognize with this one is they share this, so that one we're not going to worry about. We're not going to worry about the x minus 2. So the right one needs a what? What's the right? Right, so we need a right, it needs x plus 1, and the left needs an x plus 4. And so you can see now we're good. We're common. So this one, 5x plus 20. This is where it really helps to not have to rewrite all these. Okay, you just leave that there. You know what's down there. Plus 2x plus 2. Combine like terms, 7x plus 22. And you're done. Now write what's down there. You'll get, yeah, your final answer, you need to rewrite it. Yeah, right. You get docked on if your final answer just had dashes. Okay. All right. Everybody got that almost? Okay, we'll pause it for a second. Okay, so keep it on going here. So now this is where it kind of gets to the part, we haven't really done much factoring yet. This is where you have to start thinking about factoring because, see right here, it's confusing, right? P squared minus 1, p plus 1. Well, I can't just times by a p, okay, because that'll give me p squared plus p. So we need to be like, okay, well, I need to see, can I break these down more? Because otherwise I don't know. Okay? You could times it by the whole thing, but then maybe I don't need to do that. And my point is that you always want to check if you can factor first. What's that? Actually, you want to factor first because factoring helps you see your non-permissibles. So like right here, Gavin, this one here, that's difference of squares, right? So now I see that it's plus or minus 1 for non-permissible. So you want your non-permissibles after you factor. Okay, and then this right here is t over p plus 1. So my non-permissibles, I can't be plus or minus 1. Okay, so now looking at that, the right side's the only thing I need to adjust. The right side needs a p minus 1. And now we're going to go ahead and we got our common denominator. We're going to do the top now. So 4 plus 2p minus 2, right? Because this right here is going to be 2p minus 2. So it's going to be 2p plus 2 over p plus 1, p minus 1. Now in this one, I want this to be factored like that. Yeah. Yeah, right. So you asked, do you want us to write p squared minus 1, or do you want to write it factored out? Always write it factored out for the bottom. Okay, that's a good question Alan just asked. So Alan knows that these two equal this, right? Don't write it as this, write it as factored form. So you see your non-permissibles and everything that can cancel. Now the second thing that's really important is that this is an example where if I pull a 2 out, what's left? P plus 1's good because it cancels. So that's the second piece here. You see that? And now your answer is 2 over P minus 1. The 4. 4 minus 2. Yeah, 4 minus 2. Oh, yeah, it was just a 4, yeah. Okay, any questions there? Now, again, the fully reduced form, you don't get your non-permissibles from there. Okay, your non-permissible still stays plus or minus 1. All right, here we go. Now we're getting into it. See, oh, now they're really making you factor. Okay. So this one factors to x minus 3, x plus 1. So that means the left and the right share an x plus 1, so my left needs an x minus 3. Yep, just factored this to that. Non-permissibles are x can't be 3 and negative 1. And now we're ready to combine our like terms on top. So 2 times x, 2x, 2 times negative 3, negative 6. This is where you can so that's where you're at. Remember, you're minusing that whole thing. So it's 2x minus x, which is x. Negative 6 minus a negative 1 is plus 1. So it's going to be minus 5. Nothing cancels. This is as far as we can go here. Is 5 a non-permissible? No. Top's cool, right? We can do 0 on top. 0 on top just means your answer is 0. That's okay. We just can't divide by 0. Okay. Bottom one. Y minus 3. Oh, no, y minus 2, excuse me. Okay, y minus 2, y minus 1. This one's going to be y plus 2, y minus 1. So these ones are missing. They're sharing the y minus 1, and they're missing 1 from the other side. So this one is missing a y minus 2. This one's missing a y plus 2. Okay. Now you can see why I was telling you about that trick about writing the italics. You don't need to keep writing all 3 of those multiple times. So the top left, this is going to be y plus 2 because it's times by 1. The top right, it's going to be 3y minus 6. And now we just combine our like terms. Y plus 3y is 4y. 2 plus a negative 6 is a negative 4.
Junior class change.
The reason I wrote the italics is because I see the 4y minus 4y, or minus 4. I can do what? Take a 4 out, and I'm left with, which I have one of those down there, don't I? So that cancels. So you get 4 over y minus 2, y plus 2. That's it. It's your simplified rational expression. Okay, questions there? What's that? Right, you factor top and bottom is kind of the final step here. So like really, again, this is what I talked about though, guys, is that like you understand the rational expressions, you understand when you cancel, you know what non-permissibles are. So what's new? Nothing's really new. They're making you factor, which we already did. That's unit 2, right? So we're kind of, excuse me, we're adding a section we've already taught you, putting it all together. So this is an example of why on a test, instead of saying, hey, factor this, show me you can factor, I'm just going to give you this question. Because if you can factor, you can do this question, right? So that's kind of the all-in-one type deal. So yeah, as Nolan just said, you clearly see here you got trinomial on top, trinomial on bottom. No, you can't knock the x squareds off. Okay, you can't do that stuff. So we got to factor. So I factor the top, I get x minus 2 x minus 1. I factor the bottom. I get x minus 4, x minus 1. Minus, I get x plus 6, x plus 4. When I get the bottom, I get x plus 6, x plus 2. So you see, within your factors, there's stuff I can cancel. And we definitely want to cancel those because that's one less common denominator we need, right? Because this one here, there's no 6's on the left. So canceling this helps me because I don't have to worry about the 6 anymore. Here, there's no 1 on the right. So cancel this, I don't have to worry about 2 now. Okay? But before I cancel, I want to do what? My non-permissibles. So my non-permissible is 4, 1, negative 6, negative 2. And now we're ready to cancel. Cancel, cancel. So I have x minus 2 over x minus 4 minus x plus 4, x plus 2. We good? Are we done? Nope. We're getting together, right? So we got to go x plus 2. I know. Jeez. Sorry. Yes. Not the bottom. This one needs an x minus 4. Now this is actually where it's cool. Joel, you actually might like this, buddy. See x plus 2 times x minus 2? What's that give you? Minus 4. It's difference of squares, right? So this is both going to give you difference of squares. It's going to be an x squared minus 4 on the top left, italics, or x squared minus 16 on the top right. So what happens to your x squareds? They cancel. X squared minus x squared gone. Negative 4 minus a negative 16 means plus 16. I get 12. We're done. 12 over x squared, or x plus 2, x minus 4. Okay, I'll pause it there, see if you have any questions. So, onward. This one. Last one. All right. Okay, so what this is the type of question that I do this in the workbook. They say, here's what I want you to do. Show me the answer is this. Okay, that's what they're saying. So you know what the answer is. You're trying to get there. Okay, so what we're going to do is we're going to factor. Okay, we only have to factor the bottom two, and you already see something that's kind of annoying, I could say. I don't like it when it's written that way. I don't like it with a squared there. We'll see why that's going to matter. It is still a difference of squares, though, yes. So the bottom left, what's the bottom left factor to? Three and 4 for this one. It's all right. And this one is 2a, and then it's going to be 3 minus a, 3 plus a. Okay, so what do you guys see? So it's written different. We'll leave it, but we do see that, do these ones, are they sharing those? We may. This we might. We'll see on that. But look at this right here. 3 plus a and a plus 3. Are those the same? So that's a common factor. We don't have to worry about those. So all this one needs is a what? A plus 4. Yeah, or x plus 4, but a plus 4 in this case. It's okay. Okay, and this one needs what? 3 minus a, right? Now we have our common denominator. Let's get the tops going. So I do have to FOIL the top left, right? Because it's a binomial times a binomial. So I do have to FOIL here. 3 times 2a, 6a. 3 times 7, 21. What? 21? 3 times, yeah. Negative a times 2a is negative 2a squared. Negative a times 7 is negative 7a. So that's that FOILed out. Let's go and put it in the right order. So that's a negative 2a squared minus a plus 21. Let's look at the right side. Remember, this is all over the 3 factors. We're adding it to 2a times a, 2a squared. Oh, I like that because why? the 2a squareds cancel. And then I have 8a. Now let's combine those. So yes, go ahead.
What canceled?
We haven't done it yet. Nothing's canceled yet, but these 2a squareds, I have a negative 2a squared plus 2a squared, they'll cancel. That's what I was talking about. Yeah. So I haven't canceled it yet. So yeah, from what Brett said, this right here, go away. So then I have a negative a plus 8 is 7a. I have 21. Okay, I'm going to write this again, italics. Can I do anything to 7 and 21? Yep. Just trying to make sure something real quick. Yeah. Okay, so it's going to be a plus 3, yep. So take a 7 out, I get a plus 3. Now my bottom, though, we're going to see if we can piece this together. This is where we get confused in our previous lessons I've done with the classes. So we clearly see why there's only a 7 on top, right? You guys see that? This a plus 3 goes away. But they have a negative 7. I don't have a negative 7. There you go, Witzke. You remember, just keep it. So see how close we are? I haven't got a negative 7 yet. They got a negative 7. Yeah, we're trying to get what they have. Right, and so what Nolan said is, he remembered from what he said earlier, is that we have this right here. See how they have 3 minus a, but they're saying a minus 3. So see, they took a negative out of that like we did in our lesson. They took a negative out of this one to flip that sign, which means a negative 7 now, because this is like a negative 1 here. 7 over negative 1 is negative 7. So what happens is it becomes a negative 7. This flips to a minus 3, and then a plus 4, which is what they... Good, because once that negative comes out, so it's the same thing if I had a negative 3 times a 7, right? Well, if I take a negative out, it'd be 3 times 7, right? And I put that negative up, it doesn't affect that second number because it's on the first one. Right, and a misconception in math is people think that, well, this negative 1 distributes. It doesn't, because they're all a product, right? And so it just hits 1, that's all you hit with it. Does that make sense? So what I'm saying is, I'm explaining in math, guys, is like, for a quick, easy example is, if I have x times 2 times 3, that is not 2x, 3x. That is not 2x times 3x. It's 6x. It just hits all together as one group. Okay, you don't distribute. What's that? Yeah, it'd be like 2x times 3, which is 6x. Yeah, you just don't hit both of them separately. Yep.